Hello, everyone. Good evening, good afternoon for those of you who are joining from out west. And if you're joining from the distant east, then it must either be pretty late in the night for you or very early in the morning for you. So thanks for choosing to be here. It is a pleasure for me to be here. I hope you've all been having a wonderful day so far. I am happy to welcome you all to the BeConnected event this evening. I'd like to introduce myself before I welcome our guest speaker. I'm Nina. I'm a data engineer right here at Chainsis, and I am working presently as a consultant for a client in the financial industry. And I'm going to be your host for the rest of this evening. So I think we're all set for the last session of the day. I am happy to welcome Dr. Soma Venkat back this year to this conference. He presented last year at BeConnected 2022 as well. And this time he'll be speaking with us about how data fuels AI growth. Apart from being a tech industry executive, he is an academician and scholar. He has been awarded a doctoral degree from the University of Windsor in computational mathematics. He also has executive management degrees from both UC Booth, that's the University of Chicago, and MIT Sloan Schools of Business. He has well over 2.5 decades of experience in taking the lead to devise and implement corporate strategies. The solutions he has delivered span across the automotive, manufacturing, high-tech, higher education, and media industries. He has held various leadership positions in firms like IXS, Meritor, ProQuest, Bell & Powell, and Oracle. He knows the data sphere inside out and is currently a senior vice president and chief information officer at Cooper Standard. Moreover, he is also one of the founders of an AI startup. And he's on the board of a company named Liveline Technologies. This is a company that aims to deploy AI in automating complex manufacturing processes. Thank you so much for being here today, Dr. Venkat. It is a pleasure, truly, to welcome you back onto this virtual stage. Before we get started with the presentation, though, I would like to remind our audience, as always, do shoot your questions over to me by typing them in the Q&A box down below in the Zoom toolbar, and I will make time for them at the end of this webinar. I'll curate the questions throughout, and I will launch the Q&A portion at the end of Dr. Venkat's presentation. Another quick note to all of you out there, someone from the virtual audience here today will be the lucky owner of a Fujifilm instant camera, and we'll find out who after this presentation. The stage is yours, Dr. Venkat. Thank you.
Thank you so much for the introduction, Meena. It's a pleasure to be here in BeConnected 2023. And thank you for the audience for staying till late. Here I'm in between you guys and a nice drink. So let's try to get to this and make it as interesting as I can. The discussion today is about how do we leverage data in the journey towards AI growth in your own organizations. So let's start off with the momentum harnessing concept here, right? So the largest taxi company does not own any vehicles today. One of the largest retailers does not own a brick and mortar store. You guys know who I'm talking about here. The largest hospitality company does not own a hotel. This is current day how transformation is happening on a daily basis. Data and technology dictate the flexibility and the art of possible to do these kind of transformations. These would not have been possible without data technology 20, 30 years ago. But today, this is happening and even more. So the questions we need to ask ourselves are we taking full advantage of insights from the market? Are we leveraging new technologies to identify areas of innovation? Is our approach agile enough that we can succeed in the marketplace? Data drives artificial intelligence in today's world. Let's talk a little bit about automotive world. Automotive world is undergoing a seismic shift. Some of the external catalysts for value include the mega trends, which are emissions and fuel economy. It's getting completely electrified, which is a huge trend in itself. After 100 plus years of running it on gasoline and diesel, we are now at a point where it's all becoming electric. That's a huge trend. And most of the time, cars are becoming transforming from being a mechanical device to almost an electronic device. The second major mega trend is the autonomy, or the fully autonomous version of how it's being driven. This is a huge challenge, not just for the automotive industry, but for insurance industries, traffic industries, transportation industries, legal industries, to see where the issues are. So the huge change is impacting across in multiple industries. So it's fully autonomous, and these two are major aspects of change happening in the auto industry. Now, these two are highly driven because of the connected vehicles and the data available to do that. To do a fully autonomous vehicle, you will need a lot of real-time data, real-time analysis, and real-time responses to stimuli outside. And that's happening because we collect the data and we move that in the speed in which it's required to make decisions. The evolution in automotive can be described in a nice way like this. Initially, we started off saying no assistance from anybody else on that. Then we took a feet off in the sense of good old cruise control. Then it became hands off, which is self-driven to some level. Now it's eyes off, and we are slowly going towards mind off as well, and which will be 100% autonomous. These kind of models require us to think differently, to behave differently, but more importantly, to try to operate ourselves in a different fashion to be successful. What does it mean? Data is required in each area. To do a cruise control, we require data. We didn't realize that. They put it out at 75 or 70 miles an hour, and you have to start tracking it. Though you don't have a foot, but you don't take it too far out. Once you do a hands-off, it started doing adaptive cruise control, where it can actually manage the speed based on what's my vehicles around. And this kind of information is all driven by data. I gave an example of an automotive company. The same can be said for any other transportation, including the whole planes industry, right? So every one ride in a plane causes terabytes of data generated at every second. So this data drives our business in my company and in many companies outside. So what is my company? Cooper Standard is a leading automotive tier 1 supplier. And we are not only a tier 1 supplier, we are also doing material science and engineering organization. We do custom engineering work and take a lot of material science information and create new materials. As a culture, we do sealing systems, and we are number 1 or number 2 or number 3 globally in most of these areas. If we do not see a path for being number 1 or 2 or 3, we exit that business. We get to another business where we can be number 1, 2, or 3 globally. So the sealing systems are those which we use in everyday cars, where we seal rubber products largely, which will help us to be safer and will protect the noise from outside. It's also the fuel and brake delivery systems, which is a big difference when it goes electric. Electric does not have that many, but it does have fluid transfer systems or coolants. There's a lot more coolants required due to the battery heat. So most of the products in Cooper Standard are highly scalable to an electrical vehicle as well. The major tagline for Cooper Standard the last few years has been creating sustainable solutions together. So there are 4 keywords, which are creation, which is common for many industries who are successful. Second is sustainable. So most of these things we do today are highly sustainable, not only based on recycle, but also lesser weight, not for us alone, but also for the auto manufacturers, and more earth friendly. Solutioning is an area where we come in and provide solutions to what's required for the company today. For example, we just got an award for being the frameless. We created new design which are without frames. If you go to most of the electric cars, the design are completely changed. We work with them to make sure that it's seamless. The other solution we provide is newer technology with saving body contour, body colored rubber. Rubber is always known as black, and we have created this without having to paint it or something by natural color. When we create these rubber compounds, it will be colored to the body. These are some of the basic solutions in the sealing space. Similarly, in the fluid space, with all the electric, we are creating new solutions, collaborating with our partners, and creating a single-handed pump, which will take the whole fluid delivery from A to B. And we have a lot of quick connects. We're connecting various fluid pumps, fluid carrying pipes together. Next slide here. So the together is a very, very important aspect, which is important for us. We'll talk more about it throughout this presentation. So the next is changing subjects into saying, what's AI? AI, as we define it, includes machine learning. It includes natural language processing. It includes computer vision. Maybe robotics is using AI. It also may use virtual agents like robotic process automation. There is some AI which is saying intelligent automation coming up. Speech recognition is a huge part of AI right now. It's not AI per se, but these are all the cognitive aspect of that, saying automatically understanding and expert systems. All these things combined to form artificial intelligence as we know it today. We can talk into each area in more detail, but machine learning and natural language processing are most commonly used today. And if you go to Bart or ChatGPT, these are areas which are already used. Machine learning is used as your models for self-learning aspects. And also we have the natural language processing to understand your word and to understand what languages what tones we talk, and to provide back a very human type response. These are aspects of natural language processing. Cognitive AI is a completely different story, and which is getting more popular with Gen AI today. But the general artificial intelligence itself is not a new concept. It was coined in 1950s in Dartmouth. So this has been there for a long time. It is getting a lot of traction the last maybe a year since the generative AI came in using ChatGPT last November. What's the potential impact of AI in global economy, right? So the potential impact is trillions and trillions of dollars, right? If you take the advanced analytics, which includes the traditional machine learning and deep learning, these are all largely data feeds into creating these models. That's about 11 to 17 to $18 trillion impact on the industry. Once we use the generative AI cases, that adds another 15 to 40% more, so another about $4 to $5 trillion to the existing AI industry on that. And this makes a total use case. These are all use cases identified to $22 to $23 trillion. Humongous impact. And so this is not something to be trivialized or to just say that this is another fad, it'll pass. Now you add an worker aspect of that, which is how it is changing the human capital management, and how are we going to have our workforce managed the next 10, 20, 30 years. The impact is humongous. You talk about 10, 20 years, it's probably going to be 5 years. Generative AI is causing a steady set 40% of our coworkers are going to be AI agents going forward, maybe in 5 years from now. And the worker productivity, even if we do not replace people, we are going to be a lot more productive, about 35 to 70% more productive. And that adds up to about $8 trillion on that. So total, we are talking anywhere between 19 to 30 trillion dollars of total AI impact. That is humongous. That's more than many, many countries in the world. Now let's talk about the fact that it's all great, but is Gen AI real? Is it really happening, or it's still people are talking about it and everybody likes to talk about it? They all have some 1 or 2 use cases. They probably are playing with it. You go put in a question, maybe your kid puts in a question and gets an answer directly, or somebody is writing a nice email using a Gen AI. Is this the real Gen AI, or is it really real that all these trillions of dollars, are they real? Let's take some examples of what McKinsey talks about. Gen AI tools are being used today. This is not something which we need to wait for too long. And people are either using it outside work or they're using inside work. If you just take inside work, about 20 to 25% of the folks are already using it across. And this is whether it's in Asia Pacific or North America or Europe, it doesn't matter the location, and it's happening. Similarly, it's cross industries, financial services or technology or manufacturing. And not only there, if you look into the job titles, which is interesting, across the board, people are using AI, Gen AI specifically. C levels are using it, senior managers, mid-level managers, and it's anywhere 20 to 25% today, and that's fast changing towards increasing much, much higher. An age group, we can't say that only the Gen X are using it. Every age group is using this thing out there, and across the gender. So I kept the gender identity, men and women, but you know what I mean is across the board, all gender identities are using it just equally. Let's talk about what are the objectives of planned Gen AI activities. If you look into respondents across high performers as well as others, you talk about they use it for about 20% in reducing costs, 25% to increase revenue. This is huge. So if I talk about increasing revenue from the core business, that's 27%, 25%. And then if I upgrade with some of the offerings I do regularly and just adapt and then enhance it with AI, like copilots and things like that, that's another 30%. So this aspect is highly prevalent today. But what are the risks? What is the one which is going to prevent us from doing AI more strongly? The risks to AI success, when we did the analysis, was strategy itself, right? We don't have the proper strategy. Data, that's a core I want to focus on. Technology, adoption, talent, and models are all to some level dependent on data. If you don't have the right data, you are not going to be successful in an AI endeavor. So whether it is any respondent or specific to the most successful respondents, the model is very similar, anywhere between 15 to 30%, 20% is data. If you include the element of data impact, when it comes down to secondary impact, that's close to 50% of all our impact is due to having correct data. So let's talk about what are the benefits of adoption, right? The benefits of adoption are two major ones we always say, right? Everything else is fluff. One is there a decrease to the cost of my running? Is there increase to the revenue? And you see across the board by each one of these areas, you see within any company, you see that AI adoption does decrease the cost and increase the revenue. By revenue in this scenario could also mean opportunities from people. And so whether it is human resources, a supply chain, or risk management, or marketing, or finance, in every area you look into that, there is a huge value to be had by adopting generic AI, but generative AI, but also regular AI, both sides. Okay. Let's continue to move on. So that's great, but we are in a BeConnected conference with Changes folks who are all pretty technical largely. Let's talk a little bit about what does my application landscape look like? Where does this really work? Largely, the Gen AI is divided into about 6 or 7 major areas of value. One is text. Still about 80% are still largely text-based. That's used in either marketing on that, sales GPT. Similarly, you talk about some of the model layer with respect to companies. These are areas at the top, talks about the areas and some of the model layers which are available. Some of them are open source, some of them are still being worked on. As for example, OpenAI GPT is completely open. GPT-4, you have to pay for it. And I think you can add on areas like bot bot falls into this. And then you're talking about some code generation, some image is a huge area which is getting popular more and more. Code generation, we talked already about not only code generation, text, SQL, and web app builders, but also this whole concept about copilots is huge. Speech. Speech is an area which is completely translating text to speech, but also speech by itself. Video. 3D is a huge model which is happening, particularly in the engineering space. It's a huge win. And then you talk about other areas of biology, and I'll talk about a little bit other areas as well. I talked about the data architecture, right? So AI is all about data. An illustrative data architecture can be easily found here, saying that what are the data sources? How do you ingest data? What are the data repositories you use? Right? What are the data services? Prompt engineering, you probably hear about it. Data API endpoints, access data. Consumption aspects of that is still, we still use data analytics and BI, but the Gen AI application is a huge area of consumption, which is happening today, which is like your front end for ChatGPT or any of them. And if I look at processing, processing is a huge area. But Gen AI processing is huge. We talk about pre-aggregate data for answering questions. So that means you already have a database or a data structure which is doing that. From a traditional side, we talk about your relational and your data warehouses. And we talk about the Gen AI has a pre-processing layer on top of that. The LLMs are called the large language models. We talked about the NLP. So the large language models are an area which is very critical in the file format level. Now, when you talk about the data model and governance, all these things cannot happen without the basics of the governance. MDM, which is a master data management, is a core area which is required for anything. Without that, none of these things are going to be feasible. It's garbage in, garbage out. The machine language and the models we need to use are using some governance of specific models for each machine language. And that requires a place to store, use, and things like that. Some of the machine languages and the models people may use, AI models could be linear regression or a Markov or any of those basic models need to be based on what data, what results you are looking for. Each model can give you completely different results if you don't use it properly. So the governance is important. The ontologies of data model is important. And then data tagging is critical. You talk about access policies. So a model itself requires governance, right? This is all the data governance, this is my model governance. These two go hand in hand for us to grow. We can talk about how we talked about DevOps. Now we have data ops, ML ops, LLM ops, live ops, and FinOps. And talks with that is your whole LLM gateway, which is traffic monitoring, logging, credential management. The whole design for security is a huge aspect on that. Now, because we deal with a lot with data, you need to really make sure that your PII protection is critical, right? So these are some of the aspects which you need to continue to work on. So talk about data and digital evolution for us, right? So you talk about the AI evolution, data plus model gives you digital evolution. And it's a very structured process. In Cooper Standard, we have a process called innovation called I3. And we use this process to define and commercialize any product we have got it through. And this process requires the opportunity using a global tech council, and it uses both the data and what's the AI model we use. These two together, if we continue to use it appropriately, they kind of roll on top of each other because each model I run, I create more data. The data is fed back into the model. So it's a closed loop process. But these two gives us the evolution which requires for us to grow. So let's talk about some use cases. I think Meena will have questions at the end. So let me continue with use cases. And a very, very simple use case. Cooper Standard does a lot of sealing products, which is rubber. And to do the rubber, we take a lot of iterations of compounds. We mix it together and create a rubber compound. And when we mix these things together, when you have to go through, it takes a long process, a lot of time and effort and money to go ahead and create the rubber just in the right compound and the right way. And that wastage, if you look into things like a good old way of doing engineering design, we used to create a car, put it inside a wind tunnel, and the wind tunnel itself used to be $1 million, $2 million to run that, and to basically calculate all the airflow pressure and all the wakes and things like that of what happens based on a model. So physically, you had to build a model, put it in a wind tunnel, and create that process, everything. That changed years ago when CFD or computational fluid dynamics came to say that, can I digitize this whole aspect? And this has really substantially improved in that model. Similarly, when I talk about compound development, as we talked about material science as a core piece of my company, for compound development, we started using AI. We did not have the right talent internally initially, so we collaborated with other universities, MIT and others, to basically get an initial. This is about 4 or 5 years ago, before Gen AI. This is regular AI. And we could find that in 5 steps, we could get the answer wanted, or taken about 20, 25 steps to do it. So the historical trends for humans, as you see right here, is using compounds improving, but it's not good enough, right? A small improvement. When I start using AI training, we use some training. As you said, it's not big difference between humans and training, but then once you start using it, you can get some peak performances much better within 3 or 4 or 5 times. And this helps me to have a huge compound development time reduction, but also gives me new way to reduce, new way to create new materials. And this gave us a finalist for the PACE Award in years ago. Now we took some of these mechanisms of how we created these products, and we created a new highly sophisticated material called Fortrex, and we are using it in multiple places, not only in automotive, but also diversify it in non-automotive areas, including athletic shoes and things like that, and footwear, and wire and cable, and consumer applications, and roofing and building construction. So these rubber aspects, which now has a lot better heat transfer properties, or color absorption properties. And this has helped us to get new forms of revenue. Remember, I showed you a lot of those, the surveys, which said that for AI to be successful, it has to have 2 major things. One is reducing cost in your business, which is important, but also you need to find new forms of revenue for your products. So that's kind of what new forms of revenue we could go ahead and start selling it outside in non-traditional industries for these. Now, I think let's talk a little bit about saying the whole aspect of saying, can we save cost? The low-hanging aspect of that are not easy to develop. So when we started looking at saying, can I start being focusing on how can we predict, right? Predict in the sense, if you look into your business, look at wastage, and can we enhance our performance? Can we improve my quality? Can I increase my efficiency, which is reduction in cost? So to do that, we wanted to see, guys, can I start collecting data? Without data, I would not know which area my focus will give me the maximum bang for the buck. So we took the pursuing the machine language, particularly the aspect of ML, and said, can I do real-time process modeling? To do real-time process modeling, I needed to get advanced industrial controls to do that. We call IIoT. So we had a lot of machines which were very old, good old German machines. From these machines are solid 300, 400 feet of extrusion machine. You put something out and you get something else on the other end. And it does cooling, heating, and a bunch of things in between. So when we wanted to do that, one of the things we found was these machines are not easily connected to internet, connected to digitizable, not very easily digitizable. So we built on our own methodology to connect them, to digitize them, so that we can collect data. Initially, we started collecting OEE data, which is my equipment effectiveness data. Then we slowly moved on to do other aspects as well. So the industrial controls is a much bigger piece, saying it's just not just collecting data, but also try to control if we find that some data is not correct. One of the areas we found was in scrap management. Our scrap control needed a much better. We are industry leaders in the lowest use of scrap. So our scrap was not high compared to our competitors, but we wanted to make sure that we reduce waste and reduce scrap substantially. So we built in a model to start collecting data. We had cameras, we had sensors built into these machines. We had a digital twin selected, and we kind of did the whole process in an area which is just for this. It's a prototype area. We just started putting it out and simulating the whole process out there and collecting data. Took a few months, and we kind of updated the models. We collected a lot of data. Based on that, we could not only discover materials, but we started saying, can I reduce that? We found that using the pressure, the correct aspect of that, we found that there are absolutely a possibility to reduce the amount of scrap substantially. So to increase that model, we created a company called Liveline. I think Meena introduced me as one of the Liveline is a spin-off of Cooper Standard that enables radical improvements in manufacturing performance by harnessing the power of AI, automating very complex processes. And in this process, we did with one of the processes we did was with respect to reducing scrap. So when we start putting in the rubber compound on one end, we found that what are the patterns we could find which is causing us a quality which is not acceptable that we had to scrap. Or at times it was startup scrap issues, where at the time of startup it was bad. So, or the speed needed to be adjusted appropriately, or there was pollution in the compound itself, which required a separate kind of handling. So these kind of aspects, we started studying it one by one. And not only studied, we found the pattern and said, can I use controls to control it before the quality gets bad? So real-time process control. And that's exactly what Liveline does, is it takes it out and say, in real time, if I say the pressure is between X and Y, it is good. So can I go back and change the pressure of the machine so that my scrap is not required to do, or the quality is still high? This requires a lot of physics, and this requires a lot of managing our data elements. And I just want to talk a little bit about saying, if I look at to collect the data first, analyze, and then model. Right. And so this extrusion machines 1 and 2 put together, how do you put that? And each parameter, right? What's a barrel level, clamp level, adapter, hose, various parameters we need to get. This is just a sample of saying what are we doing on that and how do we get the data to do that. This helped us to substantially do the closed loop feedback, right? So for each level, we started getting data. We use machine language. We changed the learning. We do the AI. This is not Gen AI. This is a regular AI to go ahead and do that piece. So we automate the creation. That means we connect it to the data, learn the optimal controls. AI controls will operate the equipment, fully automate, and this gives me the hard savings. So this is focused on continuous manufacturing systems, right? Not just batch, right? It's continuous processing as well. And if we are too complex or difficult to automate, we still can go ahead and do that using automated data. Okay. But how did we do this? The main piece is, if you open the hood of the car is when you see the fun. So it's the same way you look into that in the back. There is, I don't expect for you guys to understand all this, but this is just a data model we put together to start digitizing this whole concept in the back. Left side is all the extrusion machines coming up, right? Then we started putting up connectors and putting up the mechanism to start collecting data. And then we created digital MOs and dashboards to make sure the data is correct initially. Once you have that, we had multiple of these machines in every plant. We had mixers coming out from there, which will mix all the compounds, maybe it's a compound machine. And once I have those information, then you had a finishing cells. You had to finish that once you get it out. These all together becomes a single plant. Within that plant, we said, let's connect it to an edge network, which is somewhere here, where I collect the data locally as much as possible. I need to create the appropriate tags and standardize on the tags so that I can understand that the machine, what this one and this one, I can compare and contrast with respect to time, with respect to energy flows, with respect to the complexity of the product involved in mixing and creating. So these aspects of that are critical. On top of that, I need to have the people trained to get to that. So I won't be having time to talk about people in this call, in this particular talk, but I think the huge aspect is also your talent. You require that to be updated. And we have used to some level, at least in the technology aspect of that, to use consultants to help us to grow this faster. But at the end of the day, once you have this data cannot stand alone. So you need to have your ERPs, your SAPs, your Oracles of the world need to get in. And you probably have a local other data, which probably have labor data from Kronos or Workday, or an engineering data. In our scenario, it was a PLM or Windchill, but you probably have a Siemens or any of the data elements. You take it out. Once you take this out, you need an internal engine to go ahead and put it and create a data lake on that. Just as an aspect, once you have these things done, that gives you a result which is more palatable. Now I can go ahead and create in times per second, much more predictable aspect. So if you look into that, the higher is bad, this is better. Below green is good. So you can get to something below green once we start doing this. This is a scalable element of that we have. What are the benefits, right? So I went fast, but I think it's an important piece that we talk about some of the benefits and have some time for questions at the end. So we need to have a combination of data and the AI model to give the real value for the company. We talked about trillions of dollars, but the AI model and data are important. The back is actually our extrusion machine, right? So it's not some artificial, that's a machine. These are all the ones we collect data from. And these are all basically happening where you see the rubber extrusions happening. So a couple of things, AI, speed and scale. We can automate complex processes. It's very important to do predictive. You got to break the industry boundaries. That means diversify, but you have to be very sustainable and efficient as well. Operational metrics we get where we could eliminate 50 to 90% of the variation, as I showed you in some of the graphs. This means it improves substantially the quality and it decreases scrap for all of us. Okay, so this aspect of having modeled something where you improved your operational metrics, decreased your scrap, and also you could diversify and create new materials. It's a very powerful combination, which is required once you have the basics of the data elements correct. That's kind of your foundation for you to build on everything else. So what I talked to you earlier about having all the data elements and a lot of lines going around, that is nasty stuff under the ground. But if you do not do that well, none of the other things are possible for you to do. So with that, let me have one more slide about transformation, and then I will stop and I'll get it back to Meena for question and answers. So the era of AI and digital evolution cannot be possible without having solid data at the back. That means the basic elements of data of doing spreadsheets to ad hoc aspects of that to a systematic model. Then you differentiate yourself, as we talked about, either data strategy or your ROI detection, or really start challenging what you're doing. And transformation in this, leverage your partners. If you don't have people, go outside to get it. If you don't have the technology, go outside to get it. Changes as a great technology stack, which we have used to provide some value in our data migration patterns across. Use them to get it. Perfect alignment of strategy and execution. That's another piece we didn't talk today, but none of these things are possible if you don't have a strategy. AI and data may be the value, but it has to stick to what your goal of a company is. If a company's goal, in my company's goal was making a material science company, that's what I support. If I go ahead and create something else, a financial instrument, that's not my company. I'm not into the financial instrumentation. So it's no value of using AI to get to that aspect of that. Focus to your strategy, align to your strategy. If your strategy is to reduce scrap to increase value, if you're talking about new materials, do that piece. If you're talking about reducing inventory, go ahead. If you're talking about a human resource, reducing the number of workforce or optimize your workforce, do that. Take a problem which is aligning with your company's strategy. And I tried stating two obvious things, which is common to most companies, which is how do we increase revenue? How do we decrease cost? Keep it to some basics, and that would help to grow substantially on that. Okay, with that, I will stop for any questions. Meena, take it away. Thank you.
All right. Thank you, Dr. Venkat. This was an incredible talk. And as you just said, I will initiate the question and answer portion right now. All right. Starting with the first question. It's a big one. The thing is, AI's popularity has fast-tracked in the past year, especially on like a massive global scale after OpenAI released ChatGPT. And I think what's happened as a result of that, as a consequence of that, is that schools and online learning platforms have scrambled to introduce new AI tracks. What would you suggest, and what guidance would you give us all when it comes to learning and training ourselves in AI and Gen AI technology so we can master it and work on corporate level projects confidently?
Don't be afraid. That's the first thing I would definitely say is There's no reason to be afraid. Try it, number one. Number two is AI is a lot more accessible now. I think that what Gen AI has done, somebody gave an example, was what Netscape did to the internet. It opened up and gave a window out there and started giving a browser, made it easy to go out and get the data. That's kind of what Gen AI has done to the true AI aspect of that. It made it accessible. It made it easy. There are 2 or 3 critical areas you need to do. What is called as saying, what we use the term or what's used in the industry, it's called ethical uses of AI. There are certain aspects. You talked about universities, right? Universities are also in the process of transforming to see what's the right way to do. Most of the time, plagiarism has been out, and people have found ways that are technology available to go out and do a research to see has this report by a student has been plagiarized or not. Similarly, there are tools available to say, is your data created by AI? Did you write this using AI? So there are tools available, and each university and each educational institution has a process to say, how do you use AI appropriately in your school district, in your schools, and follow those ethical guidelines. Number one. Number two is AI in general cannot replace your innovation and your specific aspect of intelligence you bring to the company. This is very critical, right? I mean, AI is good in taking existing data. Yes, it does some hallucination, take it out, but it's very good in taking existing data and finding patterns and creating something new. So if you talk about Harvard has a nice course on innovation, which talks about the types of innovation. That's one type of innovation, right? That's a linear innovation where I take these data elements and I expand it out. But what is important is completely turning it upside down. That kind of innovation comes from differential thinking. You can't train a body, train a mind to do that. And that's an area where it has been lacking. So I had a friend of mine who's very good in using different ways of presentation, right? And he talks about the fact that drawing and things like that to explain things are not very commonly available for AI. Something it cannot doodle, AI cannot doodle, right? So these are aspects of that you need to know what it can do, what it cannot. Having said it, AI is going to impact everybody's lives. How much, what is our call? And when some of my colleagues and others ask the question, is AI going to take away my job? The question is, AI may not take your job away, but somebody using AI will. So is it going to be the somebody you, or is it somebody else? Is your question to do. So I think be bold, leverage AI technologies, use it to your advantage, and use the ethical aspects of that. Make sure you understand, right? Another aspect is don't put your data into that. You need to know what it means, right? You put your data and it's gone. There has been scenarios where companies put their confidential data in and it's gone. It's going to use it for leveraging it. Any free AI available is common, and they learn from your knowledge. So be aware of it. That's some. It's still evolving, right? It's still very much evolving, but these are some of the things which are critical.
Thank you for that. I think that would be very helpful to all of us, and especially to me. A follow-up question on that now, and you also mentioned this, you actually touched on this in one of your slides when you spoke about how important data is and how data fuels AI. But then when data volume is large, right, how do you decide which is meaningful, valuable, useful data to use? Even forgetting all the security constraints you just mentioned, because that is a whole other long discussion process. And how do we decide which data to, discard or purge from your standpoint?
Tough question. You're talking about purge?
Yeah. Like, how do we decide of all the data we collect? How do we?
Great question. I think that's a very tough question. That's an area most people do not think much about, to be honest. The concept of purging. Because I think if the more data you have, the purging is largely used towards privacy, security, than saying that it basically corrupts. So the question is, a lot of times, AI builds in the same biases which humans have. So only it has gotten faster. So the question which is important is, the only way to remove the bias in an AI system is to remove the data which brought it in. Okay, the concept of unlearning, if you talk about Eastern philosophy, they talk the huge thing about unlearning is a very core way for us to grow. Unlearning is very difficult. Once you know, to not know is not possible. So that's exactly what you're telling AI to do, is to say, guys, I'm giving you all the data, but I'm going to take it all out. Can you remove all the knowledge you gained from that? Very, very, very difficult. So the question is, there are a lot of elements of that saying data gives you the knowledge, but once data goes away, the knowledge doesn't go away. So all the biases and the good things stay on. So, but can we remove some data? What data to remove? What's relevant? It's a question. We don't have a singular answer for that. What is easy is, hey, remove all the bad data, right? And statements like, okay, what's bad? How do you define what's bad, right? Things like incorrect, right? You have your address with an incorrect zip code. Can I go ahead and take that out, delete that, and will it help? Can I update it with the right address? Would that help? These are things, once you do that, you need to rerun it. So there are aspects saying resets, right? That's why the models are very critical. So complete resets. So what happens is most of the time you would try to get a model from outside, BART or somebody else. I mean, GPT 3.5, they have a basic model. That basic model has built in a lot of intelligence, right? If you go to the free version of AI, the ChatGPT, they'll tell you I don't have any data after September 2021 or something like that, right? They have a limit on that, because that's when it learned. But all that information is stored in its memory, it's learning, it's image. So to clean that up, there is no clear method to go out and clean it. But you can create your own model. Have a date, clear your own model. So that's your way to clean. It's not just, I think your question, my understanding is not just purely data, saying how does it impact AI? If it's purely data, it's a different question. What do you clean? What's your model to clean? What's the data to clean? That is a clear model. There is some definitions in this. If I look at the traditional data warehousing principles, you have 6 types of history you keep, right? Type 0 history is no data. Once it changes, type 1, type 2 to type 6. There are different methodologies to do that. But when it comes down to AI, as I told you, lives together with data. But once it gets the data, it learns. It stores that in its memory, in its methodology. That model learns itself from there, right? Self-learning. So how do you erase it? It's a very difficult thing. The best way to start from scratch and let it grow if you have enough information to do it. And I think that the aspect which is, I think, in a tongue-in-cheek way is, we always say that once you torture your data long enough, it's pretty much going to confess to anything you want. So that is the statement which is important to do, where what models you use can give you any data, any result you want. You have to be very careful about the models you use to say what results it gives you.
True. I think that especially applies in generative AI as well, right? Because we're generating massive volumes of content, and we need to figure out ways to, set up evaluation metrics and figure out ways to determine which is going to make it.
That's why it makes it up. Meena. It just makes up at times. It doesn't know. It doesn't say it doesn't know. It just makes up some data on that. That's your hallucination aspect of it, right? It learns just like a kid, right? If you ask a kid, the kid may not say, I don't know. Just say, what is 10 plus 10? It'll say 10. Then move on, right? Without knowing what it means. So.
Yeah. Thanks for that. But all right, moving on to the next question. On one of your slides, you happen to explain how at Cooper Standard, and this is within the automotive industry, you use a structured I3 process where, you try and see how to evaluate projects and solutions before releasing them, before approving them. And connecting this back to the startup that you have founded in the past, that you have helped found in the past, how did you, handle risks? How did you kind of, wrangle with the risks, or how did you deal with evaluating the projects and the solutions that you were going to release before releasing them, since that was also in the AI space?
No, I think for us, as I told you, we did not, it's not like I had a tool and I was searching for how to apply it. I started off with a real problem. I mean, that's a very core difference, right? In my startup and other things, I'm not building a tool and then trying to find out where I can apply it. Then I need to worry about this problem. For me, I had a real problem I needed to solve. I start with the problem. And then I was trying to find which tool fits me, which model fits me. And I know my scrap is high. I want to reduce my scrap. So once I picked up the data, I put on with one model, and then I say, hey, this is great. Now I change the pressure to be from 20 to 23. My model says the scrap should be down. And scrap was way high. Right? So the only solution there is my model is not correct. Right? My data is correct because I chose the data from actual thing. So my data is correct. My model is not correct. So I kept on optimizing the model, put it out there. And then the model started doing self-learning, right? Once you have the data saying, hey, went to 20 to 23 was my pressure change, and then my scrap went up by 10%. Okay, now it's self-learn saying, okay, it's going the wrong way. Let's do it differently. So that concept is very important. So there are two aspects. One is upgrade the model appropriately, but most of the time, you have to use the right model. Right. So if you talk about most of the AI models and the machine language models, it's all about saying what's the proximity area, how close to the solution it's at, what's my statistical equivalent of that, right? So if you're talking, so those are the things which are important. So for me, it was a much more direct aspect where what's the problem you're trying to solve? Start with the problem. And this is a core thing, because if you do not have a problem, we can talk all we want and all solutions is not going to help. Right? So you got to have a specific problem. Then you can do a test of hypothesis in a much better way, rather than saying, guys, it's going to work and then find somebody else to solve it. See, and the other thing is we are taking it out and we have already found other customers. We are solving it. And so that's when we did it in my thing, we did it in one plant in one line. Then I made it into multiple lines in the plant. Then I put it in multiple plants. So the model is highly robust and highly substantial. So when we went to our customer, another customer other than Cooper, when we sold it to them, we found that it's substantially good for them immediately, because the machine language which we put together learned faster their requirement. For example, we run at X whatever meters per minute. In my extrusion machine, they go that they do Y meters per minute, right? And their pressure, their compound is different, but it will learn faster because I already gone through the iterations multiple times. And so that is a very core thing, right? If you don't have that, then it won't work. I don't know whether I answered that, but that's kind of what's critically different from doing. Okay.
You got it. Yeah. I think we have time for one more quick last question before moving on to raffle announcements. So what major highlight or takeaway do you want all of us, the audience, to leave with today?
I think it is very obvious is we talk AI, you understand the value of AI, get past the value of questioning the AI. But in industry, basic problems are not solved. Make sure your basic problems with respect to data are resolved. Without correct data, I think, Meena, you asked good questions about, hey guys, what happens if I give you wrong data? You're going to have a wrong model, wrong solution. And it's not easy to correct it. Fix your data first. It's not just master data. When it comes to AI, it's just not master data. It's your transaction data is critical. Make sure you fix your data, learn it up. To fix your data, you need to be able to identify incorrect data fast and stop that. Right? So this is very critical for you to know. Is saying fix your data. When I say data is a fuel, you need to have good data, good food to go longer. Bad food is going to hurt you. right? If your car requires good fuel, you need to have good fuel to get the full performance. If you put on the wrong fuel, it's not going to get you the right performance. It's the same thing. Data is critical for you to have AI value. I think I had enough slides to show you AI value is real. It's happening. It's here to stay. And I showed you how we use data to provide you the value, how AI can give you both in new revenue and reduce cost. So your focus, if you have one key takeaway, is understand the AI, make sure it's correct, but focus on data first. Get it done. And it's doable because it's in our hands. Okay. With that, thank you very much, Meena.
Appreciate you, Dr. Venkat, taking the time out of your schedule to come join us here and present to us today. Thank you. At this point, I am so eager to announce our second raffle winner of the BeConnected event. We have an instant camera to give away right now to one of you present in the audience here. The winner has actually been drawn. The name is in, and I actually have it right here in front of me. And that lucky person who's taking home the Fujifilm Instax camera is Gopal Shenoy. So Gopal Shenoy, congratulations to you. From what I've seen, the design and functionalities are really exciting on this product. So I bet you're thrilled to win this and you can't wait to unbox this and start shooting and start printing instant pictures right away. But yeah, congratulations to you. I would actually like very much to send that over to you ASAP. So I am going to share my screen and get one of my contact details slides up here. Give me just a second. There it is. Okay, I hope you guys can see my contact details. So, Mr. Shenoy, Gopal Shenoy, if you could get back to me at this email that you see here to claim your prize by November 15th, we will get that over to you. With that, everyone, it is a wrap for the day one. Thank you all for attending, and special thanks to the stellar speakers who presented here today. I would like to also appreciate Dr. Venkat once again and the other guest speakers today for the work you have all put in these past few weeks in your commitment to appear here and speak with us. Everyone, I hope you're leaving this evening with new ideas and that the takeaways from the various webinars today have been plenty. This is just day one. It's just getting started. Actually, more coming your way. I mean, we can't wait to show you what lies ahead tomorrow on day 2. Check out the agenda on our website as well for a glimpse into the conference schedule. You know what? I will actually just post that over on the chat as well, so everyone has the link. Give me just a second. Okay, there we go. Okay, so if you head over to that URL, everyone, you should be able to see the agenda for tomorrow and kind of get a look at the overall schedule for the day, to see what sessions we have for you tomorrow, the speakers, and an abstract as well, accompanying each of those topics. I think we have several of our clients, our partners and colleagues over the next couple of days. It's overall just going to be great. We will start day 2 with a talk on the role of AI ML. I'm just going to pause here for 1 second. All right, we are going to start day 2 with a talk on the role of AI ML in the world of data management. So I'll see you all back here in the morning at 9 Central, 10 Eastern. Don't miss it. See you. Bye. Thanks, everyone.